right, so we've got this little situation. Let's go ahead and draw a free body diagram of both the blocks. So for a little m, I'll be pushing it with the force F. There's a normal force on little m due to big M. There is the friction force on little m pushing it up because this surface is rough. And then I have the weight of little m pointing it down. Then for big M, I have the normal on big M due to little m. I have the weight of big M, and I have a little, I don't have any force pushing it backwards. I've just got the weight of big M pointing down, and I have a downward friction force acting on big M from little m. So we've got this third law pair here, and this third law pair here as well. Now let's go ahead and write down Newton's law for both these blocks. So for little m, I'm going to have the weight of little m balances the friction force, and I'm going to have the force applied minus the normal on little m due to big M equals little m times A. And then for big M, I'm going to have the equation, and this is the normal on big M from the ground. I'm going to have the normal on big M from the ground, fighting friction and the weight of big M to balance out. And in the horizontal direction, I'm going to have the normal on big M due to little m, and that's going to make big M accelerate. So let's see what we can do with some of this. So we want to determine the force necessary to keep the smaller block from slipping down the larger. So again, let's look at our equations. So I know the friction is going to balance the weight of the little block. That's from this equation here. And what I also know is that this is another equation. Friction is going to be the static coefficient times the normal on little m due to big M. So maybe I can do a little something with this, since I know that the applied force minus the normal on little m due to big M makes little m accelerate. Let's see if we can solve for f with just this information. I don't think we can, but let's just try. So putting these two equations together, what I'm seeing is that I can set this one equal to that one, and I can get that mg is over mu s is actually equal to the normal force on little m due to big M. I can substitute in there, so I'm going to get f minus mg over mu s equals m times a. But I don't know what a is, so let's go to our second equation. I know that the normal on big M due to little m is equal to big M times a. So why don't I go ahead? I'm going to substitute here using the third law, mg over mu s over big M equals a, which I solve for right here. So I just got the acceleration, that's part D, but now let's go back and get the applied force necessary to keep the block from slipping. We're solving for F here. So we're going to have F minus mg over mu s equals m squared g over mu s big M. Interesting. And then I'm going to go ahead and solve for f. When I do that, I'm going to end up getting that f is big M plus little m times mg over mu s times big M. So that's the solution to both these problems. I got the acceleration, and I got f in terms of all the given variables here. And so that's the solution to the free response.